With that in mind, how do we actually do this task? How do we approach a legacy code base? You sat down in front of a morass of code, and you have to first figure out, what is this code all about? Is it any good? Does it have tests? And where are the parts I need to modify? I've been told the feature that I need to add, but I got to go figure out where in the code base is the code that I'm going to have to change or extend in order to have that feature. So before we talk about doing that, I'm going to do a little aside. I call it Armandos Computer History Minute. We've had a couple of these before. This is a little bit of a gruesome and a little bit sad story, but bear with me. I'm going somewhere with it. Some people call this story the story of Mabel the Swimming Wonder Monkey. Mabel was one of several monkeys at the University of Toronto Zoology Department where they were doing experiments that involved monitoring with these skull caps with electrodes monkeys' brains as they were doing various activities, including swimming. And this is a picture of a VAX 11780, one of the most popular mini computers of its time. The VAX was running the software that collected all this data, and somebody had written these device drivers where they could basically run the device drivers for these skull caps that were strapped to the monkeys' heads off of the disk drive connector. So there was a disk that was sort of in this drive, and somebody had put a piece of tape over this switch that makes the disk read-only, because this is kind of, they were double purposing this disk drive connector as the device driver for these skull caps. And the computer had a failure. They called in a field service technician from Digital to try to fix it. And what do field service techs do, right? They got to run diagnostics. So the first thing he did was, somebody put a read-only piece of tape over this. This must be a really important disk that they don't want to have like any random data. So I'll remove that disk pack. I'll put in a scratch disk, and I'll start running diagnostics. So what do diagnostics do? They exercise the device driver interface. The device driver interface was connected to monkey skull caps. The monkey skull caps were delivering stimuli to the monkey brains that monkey brains weren't designed to handle very well. And because of convulsions, like 2 or 3 of the monkeys drowned while this field service was going on. And the field service tech was overwrought. He was going to call the Humane Society. It was badness 10,000. So it's a tragic story. Monkeys did die. But what's kind of the moral of the story, the way this is captured in the jargon dictionary, is always mount a scratch monkey. Just like you mount a scratch disk, or you start a scratch file when you want to make changes that might be potentially damaging to a known working system, always have a way to experiment on a copy of it that is potentially expendable. So that's the scratch monkey anecdote. If you're interested in more computer folklore, I would check the jargon file among other places. But that is a true story. And that means when we get the code running in development, the first thing you should do is check out a scratch branch. You know all about branches. It's one of the strong features of Git. And this is a branch that will never be checked back in. The whole point of this branch is to mess it up, make changes, break stuff. But your goal is to start by getting the code running in a development environment. And you might have to do that by doing a little bit of violence to it. You might have a different database that the schema doesn't quite work in. Or you might have to sort of monkey around, no pun intended, with different versions of gems than what was shipped with the original file just to get the thing to run. So what you want to try to do is get a setting that is similar to production, but work on a copy that ideally you don't care too much about. And there's a separate challenge that some systems might be too large to clone, right? If your software operates on a really big data set, for example, you might not be able to clone that data set in development. So in that case, you might actually have to do something like get a smaller copy or a subset of the database. Learn the user stories. In an ideal universe, there might be either Cucumber files or 3x5 cards. But if you're missing that stuff, try to find the customers. Presumably, this stuff is still fulfilling a customer need, so customers must be out there somewhere. Talk to the customers and get them to talk you through what they're doing. If it's software that's used internally at the company, the customers might be in the next office over. And just kind of look over their shoulder. Ask them to describe what they're doing. Now I'm going to add a new user. Now I'm going to look up this person's payroll record. So you're essentially getting them to talk through the user stories as if you were co-designing the app with them. What else can you do? You can try to understand the database schema. Remember that in these software as a service apps, because the thing they all have in common is persistent data that is the basis of the models, is what the models manipulate, presumably, if they use something like a relational database, there's a way to understand the connections among these different classes. And a really simple thing you can do is just run a rake task, db schema dump, and take a look. Basically, what you get out of that is something that looks a lot like migrations. Right? You get essentially a set of migrations that could be run to recreate the database structure. So you can see things like which foreign keys in which classes reference, or in which tables reference which other tables. In fact, you can go a step further, and you can view a graphical version of this, which I have an example of. Let's take a look here. So this is a graphical version of a class diagram of an app I wrote a few years ago. You can see that this class has way too many attributes. Yes, I have also committed many foul deeds in my own code. I'm living with my shame. But you can also see that this is a class that apparently is pretty important because many other classes are related to it. So what the arrows are doing in this diagram is they're basically highlighting connections between classes that have foreign keys referencing each other. This is a gem called Railroady. There's probably other gems that do this. And when we talk a little bit about design patterns in UML, you'll get a better sense of where the notation comes from. But the basic idea is that by looking at the code and looking at the database schema, you can often understand at least what some of the more important classes are and how they're interacting. As you're looking at the classes, besides just understanding the relationships among them, this is kind of a way to understand two other things about class relationships that are really useful, which is their responsibilities and their collaborators. And in fact, it might be helpful. This is a tool that you can use to do this. Some people actually use this tool when they're designing their own apps. So you can think about using this technique as you talk to your customers and you're trying to get from user stories to implementable code. But you can also use it as you're exploring a legacy code base and you start learning things about the relationships between classes. CRC, or Class Responsibility Collaborator cards, are a way that the Agile community came up with to start thinking immediately as you design your app in terms of objects and the classes to which those objects belong. So the idea is for each type of entity, which is probably going to end up being a class, you try to understand what its responsibilities are. So those are things that it does or things that it knows, and who its collaborators are, which is things that it doesn't know or do directly, but that it can work with another entity to know or do. So here's a hypothetical example from if we were going to expand Rotten Potatoes to also be able to sell tickets to the movies online. You can imagine that there's something like a showing of a movie. A showing of a movie certainly knows what the name of the movie is. It knows the date and time of the movie. But it doesn't do all these things directly. It might only know the name of the movie because there's a given movie and it has a lot of different showings in different theaters. So you might imagine movie being a collaborator of a showing. A showing could also try to figure out how many tickets are available still for that showing. But that implies that there's probably some other class that it would collaborate with, which is the actual thing you buy when you buy a ticket. So you could kind of make these cards up. And if you don't get it right the first time, that doesn't matter, because you refine your understanding as you work through the application. But it's a way of trying to understand, basically putting a little bit of meat behind those graphical diagrams, right? Understanding what are the things that this class does all by itself versus which things does it have to interact with other classes in order to do. And as I said, I'm actually a fan of using these at the design phase as well. How do these sort of map onto user stories, or what's the relationship to user stories? Well, here's a really simple guideline. If you go through your users, and by the way, I didn't list basic command of English grammar as a requisite for this class, but I'm going to assume that you have that anyway, and that you know what a noun is and what a verb is. If not, you need to watch Schoolhouse Rock. But a really simple thing you can do is go through the user stories and put all the nouns and highlight all the nouns and highlight all the verbs. So I've highlighted the nouns in red and verbs in blue in this example. And roughly speaking, nouns tend to become things that are like entities, right? So patrons, showings, movies, tickets, and orders are candidates for things that could be a class. And attend and add tend to be methods that those classes will implement. So somebody, so when I can attend a showing of a movie, that there's someone who is doing the attending, and that establishes a relationship between the attendee and the thing being attended. So you can see how this starts to kind of tie to the user stories as well as how you'll do your class design. We'll talk a lot more about this when we do design patterns. But when you're reading the code or reading the user stories for legacy app, this is a collection of things that you can do to sort of help get yourself familiar with it over time. And by the way, creating this documentation should help whoever's coming after you as well. There's also a lot of informal documentation that you can look at besides the code base. So we already know that you can run a variety of metrics on the code base, like reek, flog, flay, to look at duplication and look for design smells, complexity, Psychro for computing the ABC scores, which Dave talked about in an earlier lecture. And we also know that there's tasks like rake stats that will give you sort of static measures. Just how many lines of code are there? How many lines are there in each? Which are the most? Which are the files that have the largest number of lines of code? Which is the what's the code to test ratio? The number of lines of test code versus app code. What are the most important models used in controllers, right? You can tell not only by which ones have a lot of code in them, but they're also heavily connected when you investigate the relationships. And if you had Cucumber and specs, that would be even better. But you can also look at the less formal things, like if there are still lo-fi UI mockups, like the kind that you've been doing to design your own new apps, and user stories, even if they're just on 3x5 cards, you can leverage these to start to get inside the designers' heads. There might even be like news groups, mailing lists. There might be a wiki or some other internal documentation where nobody wrote design documents, but there are design discussions that you can capture. In GitHub repos, we talked about the idea of pull requests serving the purpose of mini design reviews. If the GitHub repo has a pull request history, that's another good place to look so you can see how the code has evolved. There are packages that people use like Campfire and Basecamp. These are both software as a service that are specifically for this kind of thing. They're for keeping track of design review notes and stuff like that. So if those are available, that'd be a place to look. Of course, Git log. The logs can be verbose, but sometimes if you search enough, you find some really useful information in there. And of course, RDoc documentation. You've already seen this, but we're going to take a look at an example of RDoc in. So RDoc is kind of like JavaDoc. You can embed comments and markup into your source code, and those things can be automatically processed by the RDoc tool to produce nice documentation pages. As a really simple example, and we're foreshadowing here the example I'm going to use for refactoring, you can see that I've put some instance variables in plus signs. I've got a bulleted list of parameters. And the RDoc documentation, there's plenty of cheat sheets, but just so you see what it looks like, you've already seen what RDoc looks like because the Rails documentation mostly looks this way. The style sheets have changed somewhat, but this is the output of what I just showed you that was the markup embedded into the code. So if you're lucky enough for the code to have RDoc documentation, you should certainly be looking at it. If not, as you're improving the code by adding your own comments, it doesn't cost you much to essentially add them in an RDoc format so that they're easily extractable. So summarizing how you explore a code base, you can start by kind of sizing it up. Run statistics on it using Rake, look at metrics reported by tools like Flog and Flay. Use tools like dumping the schema or a class diagram creator like the Railroady gem to identify what are the most important classes and relationships. In a SaaS app, it should not surprise you that most of the important classes are likely to be models and how they're connected to other models. What are the important data structures? So again, looking at the database tables and understanding the foreign key relationships. And the whole process, the whole goal of this process is to identify the places where you're going to have to make changes in order to do your own refactoring. And as you're doing all this, anything that you can do to improve the design documentation is going to help the people who come after you. So if the easiest way to understand something is to draw a diagram, draw a simple diagram. If it's easier to sort of just add documentation to a wiki or to some other design repository, you can do that. And if all else fails, if you're putting comments into the code, make them RDoc compatible comments. So here's a question, and this is a question based on trying to understand an application. So in my view, trying to understand an application and trying to design an application are like two sides of the same coin. Because when you're trying to understand an application, what you're trying to get at is what was the designer thinking, or what were the designers thinking when they came up with the relationships they did between the classes. So let's look at a question here to help you exercise that skill. Here's a statement about the hypothetical feature of allowing Rotten Potatoes to sell movie tickets. And here's the functionality we want. Patrons, those moviegoers, I guess, can make donations as well as buying tickets. For donations, we need to track which fund they donate to so that we can create reports showing each fund's activity. This is actually based on a user story that I created last year. For tickets, we need to track what showing they're for so that we can run reports for each show. So think of a show like a movie. Plus, there's other things about tickets that don't apply to donations. Like tickets can expire. If you don't use them by a certain time, you can't exchange them anymore. But of course, a donation never expires, even though just like a ticket, it's a thing that you buy. So here's 4 possible statements about the design of an application that would support this feature. And the question is, which of these statements is the least compelling to support this design? That donation is a class that will have 3 collaborator classes. That donations and tickets are going to be 2 classes that probably should have a common ancestor. That donations and tickets should implement some sort of common interface, like being purchasable. And that donations and tickets should implement a common interface like reportable. So which of these 4 is the least compelling in terms of supporting this design?